We review a lot in this program because I really want to drive certain points home, right? It's easy to forget things, especially when it was like 5 hours ago since you heard what is Parkinson's and the definition and all that. So in this slide, quick review. Parkinson's disease is a progressive degeneration of the central nervous system. Okay? It's a neurodegeneration. In this slide, 2 slides coming up, we're going to go through again and explain exactly what's happening in the brain so we can keep this in mind as we move forward. This is a little refresher. We are looking at the substantia nigra at the bottom of the screen on the left, let's say. We'll start with that one. This substantia nigra represents that of a healthy person, somebody without Parkinson's disease. And in this slide, we're talking about how dopamine gets from, let's say, the substantia nigra to the striatum. So this is an example of an illustration of nigrostriatal degeneration. Okay, because this dopamine needs to go, this neurotransmitter needs to go between various brain regions so it can tell our body what to do through our central nervous system. So we look at this lower left figure, and you see the green circle around the dark line. Okay, well, that line is dopamine. All right, it's dark. That whole butterfly-shaped unit there in the figure, at both the bottom left and the bottom right, those are substantia nigras. Right? Remember, it's a very old, very primal movement control center for humans. Right? And so it's one of the movement control centers, and it's a primal one. And this is a dopamine production center. So when it's functioning optimally, what you see is a communication going out. Now, this would be the red lines going over to the striatal area. When you look at those lines coming out of the healthy substantia nigra, which has a dark, thick line, meaning it has plenty of dopamine, well, there's plenty of dopamine going to the striatum through these red lines. Let's call them neural pathways or whatever. Bottom line is those lines are red. They're solid. Color lines doesn't really matter. They just happen to be red. But they're solid lines, right? Okay, so it's a solid connection going from substantia nigra to the striatum. Look on the bottom right. This, you'll see the green circle circling a darker area, except that dark area is not as dark in this substantia nigra as it is on the bottom left figure, because this represents a person with Parkinson's disease. So diminished dopamine production because brain cells in the substantia nigra are dying. All right, so now there's going to be less communication, less neurotransmitter, less dopamine going between the substantia nigra and the striatum. Right, so look at these lines, okay? Look at the red lines. Those represent the, let's say, the degree that the dopamine or neurotransmitter is getting to the striatum, and you will see that not only are the lines thinner, all right, but one of them is a dotted line. Okay, so you're not going to get that nice clear shot right to the striatum from the substantia nigra because one of them's broken up, the other one's thinner, so it's just not going to be as effective. You're not going to get that communication. This is going to lead to problems in movement. When we look at the dopamine transporters, you're going to see in these images the difference, okay, and the activity in the brain. So let's look at activity in a control subject. This would mean a person without Parkinson's disease. There are 2 areas I really want you to pay attention to. Number 1 is the 2 bright yellowish figures there. Again, that's substantia nigra. There's plenty of dopamine, so guess what? They're okay. And you can see there's more red area as well. So there's more stuff going on. There's more dopamine getting to other brain regions versus the image on the right where the yellow images, the substantia nigra images, are not as bright. So this would lead us to believe that Parkinson's may be at stake here. It might be what we're dealing with. And there's less activity in the brain overall. When you look at the red, there's less red because there's less neurotransmitter, less dopamine getting from the substantia nigra to the rest of the brain. Now, Just a quick review here. When people have a DAT scan and they come out with these images, for example, especially the one on the right in particular, it doesn't mean positively that it's Parkinson's. Although in this, for the sake of this slide, this person has Parkinson's. But it could be one of three diseases. Okay, either Parkinson's disease, MSA, which is multiple system atrophy, a terrible, terrible, nasty cousin to Parkinson's, or PSP, progressive supranuclear palsy. The second two, which are much, much less common than Parkinson's. So typically, when you see an image like this one on the right, well, it's going to likely be Parkinson's. But it's possible it could be one of the other two, and that's for the medical world to figure out, for the neurologist to figure out. But there you go. A quick review of what it looks like in a Parkinson's brain with this type of imaging.